Hey guys, talking about exponential functions. Exponential functions base A. And that phrase right there, base A, is important because if you'll notice, my variable is not my base. My variable is actually my exponent. And those are what makes an exponential function. It's important to understand for f of x equal to a to the x power that x is a real number and a must be greater than 0 and not equal to 1. And to visualize this, we'll be able to, we're going to look at this uh, graphically to help be able to present that understanding. And basic exponential functions can look like this. F of x equals 4 to the x power. G of x equals 2/5 to the x minus 1. Variety of things that we can have. The main thing to note is that my variable is my exponential power. So for these problems, what I encourage you to use is technology, and I'll show you why whenever we do an example, because a lot of your homework problems are going to be graph this exponential. And if you do it by hand, it's not difficult. Anytime you graph by hand, it takes time. The difficult part isn't doing the calculations, it's actually being able to graph it. And to further explain that, we need to do an example so you can visualize what I'm saying. So TI-83, 84, or whatever scientific graphing calculator you have, or you can use Desmos.com. There's also an app for your smartphone that you may download and use. Okay, another thing introduced in this chapter is the number e. The number e is an irrational number like pi and phi. Pi and phi. Irrational numbers go on forever. Do not repeat, do not terminate. So the number e is very much like that, and you will see these in the problems. Also, f of x equals the number e to the x, and g of x equals the number e to the negative x are a couple of examples from what you'll see. Again, pi and phi. So the first thing that I want to do is to talk about properties of exponential functions. And this is a review of everything that we've already covered. We should know all of these terms, so we should be able to talk about each one and then have an understanding of it. I will be kind and I will offer an explanation for each one. Continuous, no breaks in the domain, so it's just a continuous graph. 1 to 1, this means that I take my exponential function, and whenever I find the inverse of it, there is an inverse relationship, but that inverse relationship results in two functions. The domain is all real numbers, so from negative infinity to infinity. Parentheses means you do not include, and we can include infinity. Infinity goes on forever, so that's why we always use parentheses. But here for range, our range is between 0 and infinity, but it does not include 0, parenthesis. Otherwise, square bracket would mean that it includes 0. It is an increasing function if a is greater than 1, meaning my base is greater than 1. It is an increasing function. It is a decreasing function if a is between 0 and 1, meaning fractions. Anytime you see this, this is a way to describe fractions: 1/2, 3/4, 5/8. Okay. Horizontal asymptote is the x-axis. Y-intercept for all of your exponential functions is 0, 1. Those are the property of exponential functions. So what I want to do real quick is I want to show you graphing by hand, and then we're going to use Desmos to look at some graphs. But if I were to graph by hand, so if you want to pause this and be able to look at it, look at it. I'm not going over everything I have written down, but for what I have a function, g of x equals 3 to the x power. And what I've done is I've just chosen 7 points, and the interval along my domain is a very simple interval, -3 to 3. But what I want you to look at is the range, the interval of the ranges that I get just from that. I go from this small number, 0.037, that's a -3. That's my input, that's my output, to here, 3 and a 27. And trying to be able to graph that, because my range is going to really expand. That's what happens with the exponential functions. Because here's an example. At 4, I'm already up to 81. So it is very difficult to graph. So hear me out, and we're going to graph this, and I'll show you the why. But I wanted to point out something just as a review to make sure you guys know how. Whenever I have a base to a negative exponent, that actually means it's in the denominator. So I write 3 negative 3. I can rewrite it as 1 over 3 to the third, which is 1/27th, which gives me my decimal point. And there is 3 to the negative 2. Okay, I would go through and I would work all these. Well, this is not hard math. So if I have a graphing calculator, I can easily use my table function in there. I can enter in my function, and then I can go to table and set up my parameters and click over, and then I can have all these values and go through and write them. But then I'm still going to graph it by hand. Whereas I can just use my graphing calculator, program it in, hit graph, and there's my graph, and I'm able to look at it. Same with Desmos. So to me, and this is the advice I'm giving you, once you see how it is to graph, is that it's so much easier to use your technology to be able to view the graphs of this. So what I do want to point out is that if you're given something like this, a to the x, you type in most of your calculators. You got to figure it out for your calculator. This is your power button. Okay, so you type in your base, and then you would hit that, and then that allows you to put in the power. So for instance, if I had 3, and I'll write it like it is in the calculator, 3 to the 4th. That means it's going to a power. I type 3, hit the power button, and then put in 4, and then hit enter. And all of y'all should have an e to the x button. To use Desmos and make a power, push Shift 6. That's that little symbol over the key on your keyboard, the number 6. You'll see that little symbol. That's going to make it become a power. So with that said, for graphing with calculators and Desmos, I just want you to be able to see how difficult it is. So for my very first point, it's going to be really, really small. So even if I said, okay, this is 5, this is 10, this is 15, it is so difficult then to try to find that actual value. So I'm just speculating. It's going to be somewhere there. And then for 2, I'm going to try to make it just a little bit higher. And for a -1, it's going to be just a little bit higher. Now the one point that will always be true is this. That's your y-intercept. That point will always be true. 0, 1. And then whenever x is 1, y is 3. And whenever x is 2, y is 9. And I'm just going to put them on there. And 3, x is 27. It's going to be all the way up here. And whenever 4, it's going to be all the way up here. Let's just say. So I know my x-axis is my horizontal asymptote. It's never going to touch the x-axis. It's like its border. But otherwise, what I'm going to end up doing is graphing something like this. And by hand, it's really not that difficult, but it's not precise. Again, I just threw in some estimates of where that would be. And that may be enough to be able to answer your questions. They're not going to give you functions that really look similar, the graphs of functions that really look similar. Look at the scale that they give on there. But what you need to make sure that you do is have a little bit more precision. You can use graphing paper, but I will tell you, making scales to where you can fit it all on one piece of paper and be able to graph accurately is difficult. That's why I recommend using technology for these. And guys, that is it for exponential functions. So what I'd like you to do is make sure that you're watching the publisher's videos, that you're critically thinking and structuring your homework. Make sure that you know these. These are very helpful, and they'll be helpful for subsequent sections. And good luck on your homework.